So the difference between structured programming and object-oriented programming is that structured programming is older and it's more top-down logic than nonlinear. For example, in object-oriented programming, you can have function calls and the logic can go all over the place instead of just going from top to bottom. And structured programming is more concerned with procedure, while object-oriented programming is more concerned with representing models or objects. And structured programming is closer to assembly language, therefore it's lower in abstraction than object-oriented programming. A data structure is some kind of method for storing and organizing data on a computer. Examples are classes, arrays, structs. It doesn't count as data itself, but a way of organizing data. A class is a kind of data structure that can hold both data and functions, and data of different data types, unlike an array. You can think of a class as a template for creating objects. The class itself isn't a real object, but the class can produce objects. So you can think of it as a cookie cutter creating cookies as an example. There can be one class, but that class could have many instantiations. Each object has its own individual identity. So a class is a template or a set of actions and attributes, and an object is an instantiation of this template. So we can imagine that a class can be like a fruit, and object can be a specific fruit. For example, apple and oranges are fruits. Both are objects of the class fruit.
Now we learn about the constructors. So guys, what is a constructor? In C++, a constructor is a special member function whose task is to initialize the object of its class. It is special because its name is the same as the class name. It is called a constructor because it constructs the value of data members of the class. The constructor is invoked whenever an object of its associated class is created. Now we see the small example of constructor in C++. So guys, this is the example of constructor in which we can calculate the area of rectangular using constructor. First of all, we write our header files iostream.h, conio.h. In this program, class area is to created to handle and related functionalities. It has two data members, length and breadth. A constructor is defined which initialize length to 5 and breadth to 2. We also have three additional members functions: length, get length, area calculation, display area. To get length from the user, calculate the area and display the area respectively. When object A1 and A2 created, the length and breadth of both objects are initialized to 5 respectively because of the constructor. Then the member function getLength is invoked, which takes value of length and breadth from the user for object A1. This changes the length and breadth of the object A1. Then the area of the object A1 is calculated and stored in variable temp by calling area calculation function, and finally it is display. For object A2, no data is asked from the user, so the length and breadth remain 5 and 2 respectively. Then the area of A2 is calculated, displayed, which is 10. Now we see the output of this program. First of all, compile it, then run. enter the length and breadth. Length is 4 and breadth is 5. Oops. Output is here. See, the area of length and breadth is 20 and the default area when the value is not taken from the user is 10. Thank you. So guys, now we learn about the operators overloading. So before operators overloading, we can revise the topic of polymorphism because the operator overloading is a type of polymorphism. Here the process of representing one form in multiple form is known as the polymorphism. Here one form represented original form or original method always reside in base class and multiple form. Represent overridden method which resides in derived class. Polymorphism is derived from two Greek words, poly and morph. The word poly means many and morph means more. So polymorphism means many forms. The real life example for polymorphism is in C++. Suppose if you are in classroom, that time you behave like a student. When you are in market, at that time you behave like a customer. And when you are in uh, home, at that time you behave like your son or daughter. Here one person have a different behavior. This is the concept of polymorphism. Now operators overloading in C++. Here you can redefine or overload most of the built-in operators available in C++. Thus a programmer can use operators with user-defined types as well. Overloaded operators are function with special name the keyword operator, followed by the symbol for the operator being defined. Like any other functions, an overloaded operator has a return type as and a parameter list. These are the overloadable and non-overloadable operators. Now we see the example of operators overloading.
Alright, so in this video we're going to take a look at operator overloading in C++. And let's start with a couple of examples. So the first example we have here, we see that we have the integer x and the integer y, or int y and int x. And x has the value of 6 and y has the value of 4. So if we were to see this particular expression here, where we have x plus y, we know that we're doing a summation here between x and y. So that would result in the value of 10 if we were to do x plus y. Let's take a look at another example. Here we have two string variables, a and b. So the first string variable we have, a, has this particular string hey, and the string b here has the string everyone. So if we were to see a plus b, we know that in this particular case, since we're dealing with strings, this plus operator here is actually performing concatenation. So because our arguments here are different, this takes on a different meaning. So behind the scenes, we already have what's considered to be operator overloading. So what that means is, dependent upon what arguments we have for a particular operation, we can have different sort of computations going on. In this case, we have concatenation between two strings occurring. Let's take a look at another example here. So here we have a couple of player objects being created. And I'm not going to specify what the details are of the player class. Let's just assume that in order to construct a particular player object, we have to specify maybe a name, an age, a strength, and an intelligence. So each one of these has a name, a strength, a name, age, a strength, and an intelligence. So if we were to go in and do P1 and then have our plus operator P2, we really don't know what that means. We'd have to go in and define what this particular plus symbol means whenever we have two player objects. So P1 and P2 are player objects, same thing with P2 and P3. It may be the case that we're doing some sort of mathematical computation based upon their age, their strength, and intelligence for us to actually add these two particular players up and come up with some particular value. We don't know, but we could define that. And that would involve overloading this particular operator, the plus operator, for the type player. So I have some of the commonly overloaded operators specified here, such as our assignment operator, our operations for various mathematical or traditional mathematical operations, addition, subtraction, multiplication, division. Of course, these could take on very different meaning depending on what objects we have. Same thing for our shortcut operators, our comparison operators, and even our insertion and extraction operators. So if we wanted to be able to do cout and then specify a player object, then we could overload the insertion operator for the player class or whatever class it is that we may have.